Today we're going to graph a couple of rational functions with an emphasis on slant asymptotes. Slant asymptotes, like horizontal asymptotes, predict the end behavior of a function, a rational function. So our domain is all real numbers except 3. The numerator will not factor, so we have no removable discontinuity possibilities. So our vertical asymptote is at x equals 3. The degree of the numerator is higher than the degree of the denominator, so we have no horizontal asymptote. However, since the degree of the numerator is 1 more than the denominator, we have a slant asymptote. And we find that by doing division, either synthetic or long. In this case, I can do synthetic, so I will. Remember, we do synthetic division with the 0. We have a remainder. In our last chapter, that was a problem, but a remainder here is necessary. If we got a 0 remainder, that would mean we could have factored the numerator and canceled it with the denominator, which would mean we should start over and compute a removable discontinuity. In this case, our slant asymptotes equation will be y equals whatever this polynomial is. So that's x plus 5. I strongly recommend looking at the table before you start to draw. So this is x squared plus 2x minus 5 in our numerator divided by x minus 3. And let's look at the table. Our slant asymptote, our vertical asymptote, pardon me, is at 3. So the values on the right-hand side are pretty high, and the values on the left-hand side are not as high. So we're going to draw, this low. Okay, I'm going to put in some dots for my slant asymptote, 2, 4, 5. And then I'm going to use my highlighter. Draw my slant asymptote. My vertical asymptote is at 3. Alrighty, so let's go back and grab some of those points. Negative 3, negative 2 is at 1, and negative 1 is at 1.5. So negative 2 is at 1. Oops. Negative 2 is at 1. Negative 1 is at 1.5. And 0 is at 1.7, and 1 is at 1. 1.7, and 1 is at 1. Okay, so we're seeing it's approaching the bottom side as it goes out of town and headed down the vertical asymptote. Again, you can plot as many points as you feel necessary. It will be necessary to get a good look. On the right-hand side, we're getting 4 is at 19. I know 2, 4, 6, 8, 10, 12, 14, 16, 18. I won't be able to graph that. But 5 is at 15. 2, 4, 6, 8, 10, 12, 14, 15. And 6 is at 14 1/3, and 7 is at 14 1/2. 14 1/3. 14.5. And then we're back at 15. So we're back at 15. Okay, so we have this sort of approaching going up the vertical asymptote. And if you take a look at the graph now, that actually, no piece of the graph was shown up here because it's outside the window. So that's why we want to use our table rather than the graph to assist us. Here's the second one. Again, the degree of the numerator is 1 higher than the degree of the denominator, so we do not have a horizontal asymptote. Since the degree of the numerator is 1 higher than the degree of the denominator, we have a slant asymptote. A remainder, good thing. So our slant asymptote is at y equals 1x minus 3. So essentially x minus 3. And I peeked at the table for this earlier, and there's a lot of action pretty low. So I'm going to start pretty high. Right, so let's put our asymptotes in. Our slant asymptote. And our vertical asymptote at -2. Let's punch this into the calculator. We have x squared minus x minus 7 divided by x plus 2. And let's go out to our table. Okay, so we've got -5, -7.6, 2, 4, 5, -2, 4, 5, 6, 7.6, -4, -6.5, -4, 2, 4, 6. Oops. I think I miscounted that other one. 2, 4, 6.5. Let me relook at that. -7.6. 2, 4, 6. Oh, it is. Sorry, we're not there. -3, -5. 3. Oh, this is tracking really, really close this way. So close, I made a little mistake. And on the other side, 1, -5, -1, -5, -1, -2, 4, 5, 0, -3.5, 0, -2, 3.5. Okay. Again, we're seeing really close. -1, no, +1, -2.3, +1, -2. So it is really hugging these asymptotes. Again, zooming up and down the vertical and traveling out of town on the horizontal. I mean the slant. Let's peek at the graph now that we've got an image for ourselves. Yep, that's what it looks like. Here we have domain, all real numbers, except x is not -3. If we stop paying attention and just say, oh, the degree of the numerator is 1 higher than the degree of the denominator, we're going to miss the fact that this look is also the look of a really good friend. We do have a removable discontinuity at -3, -15. Vertical asymptote, no. Horizontal asymptote, no. This is just a line with a hole. So please don't miss opportunities. 2, 4, 6, 8, 10, 12, -12. Slope of 1, but the hole is at -3, -15. So this line has a hole in it, right here. Okay, so try slant asymptotes. I know you've done them before.